Welcome to Vinsud YouTube podcast. Today we are going to read the science topic from the Hindu newspaper on February 5th, 2023, Sunday morning science news. Let's start with the first headline topic. Deer may serve as a reservoir for old SARS-CoV-2 variants. By the Hindu Bureau. A study has found widespread infection of white-tailed deer with SARS-CoV-2 virus across the U.S. state of New York. The RNA of the virus was detected in 17 of the 2,700 samples collected during September to December 2020, and in 583 of the 2,762 samples collected during September to December 2021. The researchers found circulation of the alpha, delta, and gamma variants in the white-tailed deer months after they were last detected in humans. Of particular concern is the fact that the viral sequences recovered from white-tailed deer were highly divergent from SARS-CoV-2 sequences recovered from humans. This implies rapid adaptation of the virus in white-tailed deer. The study found multiple spillover events from humans to deer of the alpha and delta lineages. While the precise implication of these mutations in enabling the virus to spread between white-tailed deer and from the animals to humans is yet to be determined, the very presence of SARS-CoV-2 variants that is no longer in circulation among humans arises the real possibility of the white-tailed deer serving as reservoir for variant SARS-CoV-2 strains that no longer circulate in the human population. The virus is likely to have jumped from humans to white-tailed deer during feeding or targeted baiting of hunting prey. The results of the study were published in the journal Proceedings of the National Academy of Sciences. It was already known that the ACE2 of white-tailed deer share a high similarity to the human ACE2 receptors, and this similarity, it was predicted, will allow the virus to bind and enter the cells of deer. If silica predictions too showed the animals to be highly susceptible to infection by SARS-CoV-2 virus, intranasal inoculation of the virus in white-tailed deer led to infection, replication and shedding of the virus, and eventual transmission from one deer to another. That white-tailed deer is broadly distributed in North America with an estimated 30 million population is a concern if the animal turns out to be a reservoir for the virus. The researchers confirmed that the virus collected from the deer during 2021 was infectious and active virus replication was proven in laboratory studies. While the Delta variant was found in human samples and coincided with the detection in deer, the alpha and gamma variants were rarely in circulation among humans between September and December 2021. These observations highlight the need to establish continuous surveillance programs to monitor the circulation, distribution, and evolution of SARS-CoV-2 in white-tailed deer populations and to establish measures to minimize additional virus introductions in animals that may lead to spillback of deer-adapted SARS-CoV-2 variants to humans. Let's start with the second headline topic. Climate change will increase hydropower generation. There is greater likelihood of increased hydropower generation, but the risk arises from very high inflow due to extreme rainfall, especially when the reservoirs are already full. Challenges to reservoir operations. If reservoirs receive heavy inflow when already full, it can create a flood-like situation when water is released suddenly. Second highest. Hydropower accounts for 13% of power generated in India. First point. The study looked at increased rainfall in the catchment areas and the resultant inflow into 46 major reservoirs located in North, Central, and South India. Second point. Due to warmer climate, hydropower production may increase across the country due to increased rainfall leading to more inflow 7 to 70% to the reservoirs. Third point. Compared with dams in South India, dams in North and Central India are projected to receive higher rainfall and inflow. Fourth point. 8 out of 11 dams in South India are projected to experience a decline in hydropower potential. Fifth point. Most of the increased inflow into the dams is expected to come from extreme rainfall events. Sixth point. Increased and sudden inflow due to extreme rainfall, especially when the reservoirs are already full, will pose a challenge to reservoir operations. Seventh point. Reliable weather and inflow forecasts are needed to maintain storage that can accommodate high inflow due to extreme rainfall. Moving on to the passage. By R. Prasad. Unlike coal-powered power plant, hydropower, which is the second highest power-producing source at 13%, is a significant contributor to clean global electricity generation. Based on observations and climate projections, a two-member team from IIT Gandhinagar studied the hydroclimatic changes in the catchment areas and their implications for hydropower generation in 46 major dams located in North, Central, and South India. The team looked at the increase in rainfall in the catchment areas and the resultant inflow into all 46 major reservoirs in the near 2021 to 2040, mid 2041 to 2060, and far periods against the reference period for two shared socio-economic pathway scenarios. 1 South Sudanese pound at 2.6 and 5 South Sudanese pounds at 8.5. While 1 South Sudanese pound at 2.6 is a low-emission scenario, 5 South Sudanese pounds at 8.5 is characterized by high radiative forcing by the end of the 21st century. Projected increase. Under warmer climate, we expect hydropower production to increase across the country due to substantial increase in precipitation leading to increased inflow to the reservoirs, says Dr. Vimal Misra, professor at the Department of Civil Engineering at IIT Gandhinagar, who led the study. Based on selected hydroelectric dams, the projected increase in hydropower potential in India is 10 to 23%. The results are published in the journal iScience. A warmer and wetter climate is projected to bring about 5% to 33% increased rainfall. As a result, hydropower production is very likely to increase by 9% to 36% for most dams, and this will come from increased inflow of 7 to 70% into the dams. The dams in central India show significant increase compared to dams in North and South India, but most of the increased inflow into the dams will come from extreme rainfall, and herein lies the risks to water storage in the dams. Professor Misra says, due to global warming, there will be a simultaneous rise in extreme inflow and high reservoir storage conditions for most dams. Our study highlights the high likelihood of increased hydropower generation, but the risk comes from very high and sudden inflow due to extreme rainfall, especially when the reservoirs are already full. Any further increase in inflow when the dams have already reached their maximum storage capacity can pose challenges for reservoir operations. He says, reservoirs can help prevent flooding, but when they are already full and if the inflow is high, then the dams can create a flood-like situation due to sudden water release. Chennai in 2015 and many places in Kerala in 2018 witnessed massive flooding due to heavy inflow into already full reservoirs. Compared with Central and South India, North India is projected to experience higher warming in the future. As per the study, the highest warming is projected for North India, while the warming is projected to be around 3 to 4 degrees Celsius for Central and South India. Similar to substantial warming, most reservoir catchments are likely to witness increased precipitation due to global warming. Both North and Central India are projected to receive a higher increase in precipitation than South India. The increased precipitation will alter the inflow to the dams more in North and Central India than South India, and also hydropower generation. Professor Misra says, the study found that inflow to a few dams in Ganga, Mahanadi, Brahmani, and West Coast river basins is projected to decline in the future. This reduction in inflow is due to increase in atmospheric water demands in response to the considerable warming compared to increase in precipitation. Timeline of changes. The projected change in hydropower potential is the highest in the FAR period -5% to 62.8%, and the lowest for the near period 6.2% to 39%. The potential hydropower generation is projected to rise by more than 50% in Tari, Ramganga, Kadana, Ankareshwar, Maheshwar, and Suram Sagar dams in the FAR period, he says. In the case of South India, 8 out of 11 dams are projected to experience a decline in hydropower potential. Dams in central India are projected to experience a more substantial increase in hydropower generation than North and Central India. Substantial warming projected for North India may reduce snow and glacial storage, reducing snowmelt water contribution in the long run. But a substantial increase in rainfall is more likely to compensate for the reduction from snowmelt in North India. Our findings provide crucial insights into projected changes in hydroclimate and hydropower for the major dams in India, says Professor Misra. India may have to change reservoir rule curves on how much storage should be permitted at different times during the monsoon season. Let's start with the third headline topic. Magnetite in roadside dust reveals source of pollution. Editor by Vasudevan Mukund. Geologists at Jadavpur University have found that they can get a preliminary sense of the pollution in an area by collecting roadside dust and testing it with magnetic fields. The technique reveals the presence of different magnetic elements, and by tracing them back to specific sources of pollution, the researchers could tell which sources were dominating in different places. Their study is in the area of environmental magnetism, which is magnetism as it depicts the impact of climate change, pollution, and environmental footprints on magnetic minerals present in environmental samples such as soil, dust, and sediments. Rimjim Mehdi, who has completed her PhD from the Department of Geological Sciences, Jadavpur University, and is the study's corresponding author, told The Hindu in an email. She and her colleagues collected roadside dust samples from 50 locations in Kolkata in 2016 using a brush and a scraper, dried them in the lab to remove all moisture, and tested them using a magnetic susceptibility meter. The extent to which a material becomes magnetized when a magnetic field is applied is its magnetic susceptibility. They also studied the shapes of the particles in each sample under an electron microscope. Their results were published in the January 2023 edition of Current Science. They found that the amount of magnetite was proportional to the traffic on a given road. It is produced when fossil fuels are combusted in vehicle engines. Using the microscope, they were able to classify the particles' surfaces as rough and meld-like. According to their paper, meld-like structure of these particles is due to the high temperature combustion of fossil fuels. They also wrote that angular iron-rich particles are considered to have been emitted by vehicles having abraded and corroded vehicle parts, piecing together. In this way, the study pieces together a coarse yet indicative map of Kolkata's near-ground pollution and its sources. Broadly speaking, the method in the paper looks useful for mapping dust loading on the roads, a very useful number for calculating road dust resuspension emissions. Sarath Gudakunda, founder, director of Urban Emissions Info and an independent air pollution researcher, said in an email. But Dr. Gudakunda was concerned that it was a manual method, not automated like air quality monitors. Although our sampling procedure required manual intervention, in this process we can easily collect samples, Dr. Mehdi responded. We don't have to follow any lengthy process to collect data. We can collect samples like road dust using very cost-effective tools, and the instruments used made the sample analysis very cost-effective, less time-consuming and more constructive than chemical analysis. Dr. Mehdi continued, we are planning to do further studies to identify the usefulness of this cost-effective and less time-consuming method as a pollution proxy and apply it to detect the pollution in any environment globally, and that it could be very helpful for economically developing countries. She also said, if each and every industry has its own environmental management team, it can easily study the level of pollution periodically and seasonally using this cost-effective method. Let's start with the snapshots. First snapshot. Study finds 3 different mixtures used for embalming. Specific ancient Egyptian recipes for chemical mixtures used in embalming different human body parts have been identified. The mummification process involved the use of many different embalming substances. Researchers found 3 different mixtures that were specifically used for embalming the head, and other mixtures used for washing the body or softening the skin. Second snapshot. Mammals living in groups generally live longer. Mammals that live in groups may generally live longer than members of solitary species, suggests a new study. The findings are based on an analysis of nearly 1,000 mammals, including the golden snub-nosed monkey, bowhead whale, and horseshoe bat, and may improve our understanding of longevity in these species. They found that group-living species generally live longer than solitary species, supporting the correlated evolution of social organization and longevity. Third snapshot. Machine learning combs radio signals from space. Researchers have presented a machine learning method that could be used to identify unusual radio signals from space while filtering out interference. They applied the method to more than 480 hours of data from the Robert C. Byatt Green Bank Telescope, observing 820 stars. The method analyzed 115 million snippets of data, from which it identified around 3 million signals of interest. Finally, it identified 8 previously undetected signals. Moving on to the question comer, titled as Chemical Origins. The question, what is the origin of Earth's volatile chemicals? By analyzing meteorites, researchers of Imperial College, London have uncovered the origin of Earth's volatile chemicals. They found that around half the Earth's inventory of zinc came from asteroids originating in the outer solar system, the part beyond the asteroid belt that includes the planets Jupiter, Saturn, and Uranus. To carry out the study, the researchers examined 18 meteorites of varying origins, 11 from the inner solar system, known as non-carbonaceous meteorites, and 7 from the outer solar system, known as carbonaceous meteorites. For each meteorite, they measured the relative abundances of the 5 different forms or isotopes of zinc. They then compared each isotopic fingerprint with Earth samples to estimate how much each of these materials contributed to the Earth's zinc inventory. The results suggest that while the Earth only incorporated about 10% of its mass from carbonaceous bodies, this material supplied about half of Earth's zinc. Hope this was informative. Stay tuned for more informative news from our channel.